Well, now if you remember previously from anything having to deal with our right triangle trigonometry, we had actually defined three special real right triangles that we use to help us define certain values. The special right triangles that we define, going in order from smallest to largest, were the angles pi over 6, which corresponded to our 30-degree right triangle, the angle pi over 4, which went with our 45-degree angle, and then the angle pi over 3, which went with our 60-degree right triangle, so pi over 3. And we know that if we actually were to put these into our unit circle, we would have arc lengths corresponding to them. And the right triangle uh, values that we would find here correspond to them. Let me point out, for example, if I take pi over 6, and I'm just going to dash this in right here, here's where pi over 6 would be, more or less. For an arc length of pi over 6, this coordinate point would correspond with uh, a ratio of opposite to, a ratio of adjacent to hypotenuse, and that would be radical 3 over 2, and a ratio of opposite to hypotenuse, that would be 1/2, right? Now that doesn't mean that the actual lengths here are 1 to 2. In this case, it's like we're saying inside of this right triangle, we're going radical 3 over 2 and 1/2 if the hypotenuse is equal to 1, so that those ratios fit. But that would fit because our unit circle has a radius of 1, and that is now our hypotenuse of a right triangle containing pi over 6 contained within our unit circle. Likewise, we can keep going right here and say, well, if we were talking about the angle pi over 4, we know that that means that that angle of pi over 4 to here corresponds to a right triangle in which the ratio of the opposite to hypotenuse side is radical 2 over 2. So we'd say radical 2 over 2 to 1, and radical 2 over 2 to 1 as well. So our pi over 4 is radical 2. Boy, that's a bad looking radical 2. Let's try that again here. A radical 2 over 2, and radical 2 over 2 as the y coordinate. That's a 2. Not a good one. That's better. Okay, radical 2 over 2. That corresponds to that right triangle. All right, let's take a look at this third one. How about pi over 3? Well, at pi over 3, we're talking about an angle that's approximately 60 degrees, so we look at the coordinates that correspond to it. Well, if this is a 60 degree or something corresponding to a 60 degree right triangle, except with pi over 3 in it this time, we know that the ratio of the opposite to the hypotenuse side is radical 3 over 2, and to ensure that we have radical 3 over 2 as our ratio, we'd say radical 3 over 2 to 1, which would make our adjacent side equal to 1/2, and that's what corresponds to our x and y values. Now, this seems unnecessarily long and complicated to have to develop this whole thing, and it's not as if every single position around the unit circle has to be developed one by one according to some formula right here. We can say a couple of basic things. First of all, we can add that if we started at 0 radians, right, 0 radians of rotation would give us a coordinate point at 1, 0, and a rotation of pi over 2 would give us a coordinate of 0, 1. Now this is important because that coordinate 0, 1 corresponds to the x and y values as if there were a right triangle that could have an adjacent side of 0 and an opposite side of 1. But there's some other nice things that we can do. Within this unit circle, we could say a few things. For example, an arc length that corresponds to 2 pi over 3 is an angle that ends in the second quadrant right here. And because we are in the second quadrant, you will have exactly the same ratio as the pi over 3 angle, except this time we'll have negative 1/2 as the x coordinate and positive radical 3 over 2 as the y coordinate. And we can go on down the list. At 3 pi over 4, we have an angle that corresponds to our pi over 4 right triangle. And corresponding to pi over 4, 3 pi over 4 is going to have negative as an x, radical 2 over 2, and a positive for the y value, radical 2 over 2. We would have 5 pi over 6 over here on the left in the second quadrant, and that would correspond to an angle that looks like this one with pi over 6, except that we would have a negative x coordinate, negative radical 3 over 2 and positive 1/2. And we can go around the entire unit circle doing the same thing. For instance, if I go into the third quadrant right here, I have a right triangle that looks an awful lot like the right triangle that I have in the first quadrant containing the angle pi over 6 within it. And so the x and y coordinates right here would be negative root 3 over 2 and negative 1/2. And it's usually at this point that when we point out what happens at 5 pi over 4 and 4 pi over 3 that we start noticing, oh, this is the same pattern in each of these right triangle positions within each quadrant. And so developing all of them is really unnecessary for us to do because we can see exactly what's going to happen next. At 5 pi over 3, we're going to get positive 1/2 and negative root 3 over 2 as the x and y coordinate. At 7 pi over 4, we're going to get positive root 2 over 2 and negative root 2 over 2 as the x and y coordinates. At 11 pi over 6, we're going to get positive root 3 over 2 and negative 1/2 as the x and y coordinates. And we can do even better than that, because if we have been paying attention, we might also notice that at certain positions, such as the one here at pi, and here at 3 pi over 2, and again at 2 pi, we know exactly what the x and y coordinates are right away. And that's a helpful thing to us because we're going to be using these coordinates to help us find the values of what are called quadrantial angles. So if I were asked to find the point xy in the unit circle corresponding to 4 pi over 3, as I'm asked to do in this answer, I'm going to go to 4 pi over 3 right here, and there it is, right? My x and y coordinates are negative 1/2 because I've got a negative x coordinate, and negative root 3 over 2. And I notice that in my third quadrant, that corresponds to a right triangle that contains an angle like the pi over 3 angle in our first quadrant, except we're in the negative x and negative y third quadrant.